All right, so our last couple examples focused on where the vertex of an angle is and how that relates to the circle and the arcs. What we're going to look at today are segments versus the angles. So we have segment relationships. Here's our first theorem. For a given point and circle, the product, so product is multiplication, the product of the lengths of the two segments from the point to the circle is constant along any line through the point and circle. All right, so you got that? That is quite wordy. Let's take a look at what that would look like with pictures and make a little bit of sense with that. So let's say that you have chord segments. So here we have a circle. Here's a chord and a chord. So up here it says for a given point in a circle. So here's the point R. What they're saying is that if I draw a segment through R, I am going to draw this way. That gives me segment, that part of that segment is A. This part is B. The product of those, so A times B, will be equal to the product of the other segment, C times D. So when you have a chord segments, they're going to intersect like that. That point where they intersect in the middle kind of splits the segment. And we're going to say that A times B is equal to C times D. So essentially from the point, we went to the circle, we went to the circle, that product is equal to, go to the circle, go to the circle, to that product. All right, let's take a look at another one. This next one is if you have secant segments. So here's a secant, it's intersecting, going through the circle, hits two spots. Same idea. Here's our point S. What's going to happen here is the product, here's one segment from S to the circle is N, and then from S to the other side of the circle, that segment, N plus M. So that product, so N times the whole thing, N plus M, is equal to, we're going to look at the other secant, from S to the circle Q, that segment, times the big segment, Q plus P. All right, again, you guys got that? All right, so N times N plus M. So that is from our point to the circle and then to all the way through to the other side of the circle. That product is equal to, from point S, the other secant. So to the circle, Q times the whole thing, Q plus P. All right, the last one is if you have a tangent secant segment. So here's our tangent, here's our secant. So it's kind of similar to what we did up here. Let's look at the secant. Z times the whole thing, Z plus Y, will be equal to X times, we have to go to the circle again, times another X. We just kind of repeat that one. So Z times the whole secant, Z plus Y. So here from point T to the circle is Z, and then you want the whole segment is Z plus Y. That product is equal to X times another X. And X times X is just X squared. All right, so let's just take a look at a couple examples, and then we've got, I think, one more video after this to continue to look at this. All right, so we're going to work on those chord length relationships. Part A, what is the value of X? So I can see this is a chord segment. So when you have your two chords from the point, Remember the product, 5 times 6, all within that same chord, is equal to the product of 4 times x. So if we write that out, 5 times 6 is equal to 4 times x. And then we just simplify and solve. 5 times x is 30. 4 times x is 4x. We divide both sides by 4. It does not divide evenly by 4, but it does give us a terminating decimal, so we're good with that. We can say that x equals 7.5. All right, part B, what is the value of y? So here's our circle. I can see we have the chord segments again. When you have chord segments, where they intersect that point T, the product of 15 times 7 is equal to the product of y times 10. See how we are multiplying portions of the same chord together. So it's 15 times 7 equals y times 10. All right, so 15 times 7, that gives us 105, is equal to 10y, and then we will divide both sides by 10, and we get y is equal to 10.5. So that's your chord segments. Our next video, we're gonna take a look at the other two we learned and get a little bit of practice with those.